Everyone. So we have come to the last session of the day. That's Hyperscale technology. Let's say DBA sleep plus 30 minutes a day. So I mean it in this one where we are trying to save more time in terms of DBA perspective and also trying to save more time with the advanced technologies what we have. Thank you to the sponsors. About myself, I'm Dr. Subramani Paramasivam, in short Manny, and I'm a regular speaker in SQL Beats, SQL Saturdays, MCT Summits, SQL Server Geek Summit, Data Awareness Programs, Data Day events, and I'm a certified trainer as well as certified solutions expert, and you can follow me on the links provided below. This is another slide. We talk about data awareness programs. So it's a free charity seminar that goes into technical, non-technical students and also parents, teachers, everyone. So I have 3 quick questions. So we have less audience here. So anyone code DBAs? Okay, that's good. Azure Development Architect? Yeah, good. And anyone to do with cloud and SQL Server geeks? So we always deal with SQL Server, we always deal with Azure now, so all cloud-based concepts, right? So it's really good to see that one. And this is the contents that we are going to cover here. So we'll be seeing something about Azure and SQL Server. We will have a deep dive on the stretch database, hybrid backups, high availability and disaster recovery. Plus we'll see some brand new tools for all of the tools what we have with SQL Server 2016 as well as with the Microsoft Azure products. So cloud rules now, and it has got loads of power on it. As you can see, we have a hierarchy here where we have management people and then business users, BI experts, DBA developers. They all make use of SQL Server cloud features. And the reason why we have that is the cloud dominates everyone. Cloud is being used by every single user across the business, across the organization, departments, everywhere. As you can see in this picture, this is the evolution what we have since SQL Server 2000 until 2016. So this is a very great feature. What we have here, main features are displayed here. So XML and KPIs introduced in SQL 2000 and SSMS and mirroring in 2005. And we have compression policy-based management in 2008. And 2008 R2 is a notable one. Here we have SQL 2012 where we introduced the cloud, and that was an evolution there. So that was very successful. After that, in 2014, we have significant new features, including the cloud, enhancements and everything what we have done that has come to a very good stage. Then with 2016, we now have very much enhanced features like R services, mobile reporting, real-time operational analytics. So plenty of features now making its way to open the doors of everyone's management side, development side, BA perspective, DBA side, and that's really very helpful. Hyperscale. What is exactly hyperscale? So in a way where we are trying to put this here, we should be in a position to scale anytime whenever is required on demand. If a customer says like, okay, I'm having a website where I'm expecting more than about 1 million visitors in a day, can you do it? So you have to scale up and you have to scale down. And now that is possible with the hyperscale concepts and technologies as well. Then we have loads and loads of data. We need to organize the data. And how do we organize it securely and also in the cloud and areas? That's there. Then the tools, what we use here. So this picture, what exactly it says is like, there is a spray there, but it's a natural way. All they have invented a tool to operate some sort of basic things is like only the upper part. The lower part is a lemon. So they just took a lemon and that extra one, you get a spray just by getting the lemon, by squeezing it directly from the lemon. So which means you have a very basic, very good tool which you can really operate it. Similarly, we have plenty of tools that is coming up, that has come up already in 2016 on Azure, which makes our everyday life much easier. Also a great architecture with simplicities around. Okay, so these are all the features. I'm trying to give you pictures to ensure that you can better understand what exactly the concepts we are talking about. And in here, we have the 2016 full built-in features we have. So we have this SQL Server industry leader, mission critical OLTP being an industry leader Microsoft. That's from the And more secure database built in what we have from SQL Server, Oracle, MySQL, SAP HANA, you can see like it's being the lowest every time. For 6 years in a row, it's least vulnerable. and we have highest performance data warehousing and a fraction of the cost when you're trying to use any of these end-to-end mobile BI device. And you have R and in-memory analytics. They all combined together, which is making SQL Server more powerful than ever. And again, it is cloud first and not just cloud only. So SQL Server 2016, before releasing, we'll say like it's totally cloud based. Of course, it does operate with cloud, and also it does operate with your on-premises stuff, but it is not purely only for cloud. It's a cloud first, but not for just cloud only. As of now, we have Microsoft data centers worldwide. Of that, Microsoft have invested more than $15 billion in their global infrastructure. And they have $9.5 billion invested in research and development. They have 200 global data centers, the cloud services, and they have trillions in transactions for billions of people who are running around the world like you and me. And they already have 24 regions currently, and 8 more regions are getting set up now. So we are going to have 32 more regions, which means it's a more powerful data centers. The data centers, what we have at the moment is like more than anyone, combining more the other 2 giants in the world at the moment. This is a simple view of how the Microsoft data center looks like. If you go to Microsoft website to look for the data centers, you can clearly see how powerful technologies that they use and how it's been organized clearly. And they're also converting into the energies into the green energy to ensure that we are trying to reduce as much cost as we could. And that is also saving the geo-replica things. And this is a generator, power generation systems, some of the snapshots that you would find in the Microsoft data center website. And we have, as of now, like we have global, central US, East US, these are all the regions. And if you visit this particular link, all you would see is like all of these features. I've only shown a simple screenshot of data and storage, but you also have plenty here, which means like you can see plenty of other views as well. Not every single data service applicable for every single services that's been provided. There are loads and loads of them, but you don't get it everywhere. Sometimes I'll show you an example of when we're trying to do a stretch database thing, where you can clearly see the errors throwing up if you're trying to do a, for example, stretch database concept. It does not work in certain region. It works only in particular regions. So it's about 75% it is accepted. And this is the view what we have, but this is not the latest from Microsoft. These are the regions what we have. So what I've done is I've taken the 24 regions plus 8 regions all together, put that into a Power BI map, and got this just for this session. And in this session, what we are seeing here is just introduction about the data centers as of now, but we'll have a deep dive into the hyperscale solutions next. So talking about hyperscale itself, like it is totally charged. What you see here is like we have stretch database, we have hybrid backups, disaster recovery, you can access it anywhere, and brand new tools and technologies. So which means we have loads of new concepts coming around. But not by the least, like in hybrid backups, you have 3 more backup devising things. So you have backup to URL, you have SQL Server managed backups, in short SSMB, and you have file snapshot backup. We will have clear demo on StretchDB and hybrid backups. Okay, before going on, have anyone tried stretch database? Not yet. But in terms of stretch database, the concept is not just like that. So you keep stretching everyone here and there, but it's about it really happens. How? People are asking for one BI person to give me this, that, everything. The DBAs have been killed, like, okay, I want this, I want this, I want that. So they want to have access to all the old cold data, but you don't have enough storage. What do? Right? So you've been stretched here and there across. So in terms of stretch database, what Microsoft is trying to do here is like, you can stretch your data from your on-premises to cloud, which means you store data in the cloud but not on your storage. When you don't store that much data on your access on-premises, you're not going to pay for it. Meaning, you can store something else for that. And you don't have to spend so much money on your data storage. You don't need to do provisioning, and plenty of features which we'll be seeing now. Before moving to that area, we need to understand the data types what we have here. So on day-to-day basis, we deal with cold, warm, and hot data. For a quick example, what I have here is like, let's say we are in December, last 12 months of data. Anything that we deal with as of now is like 3 months of data is the hot data. This is warm and that one is cold. And when you see the comparison here, this is heavily accessed as of now, but that one is less accessed. being in December and being in January. Also, any changes you have is like you have more over there, frequently changing, and you have infrequently changing. So which means like you definitely need access to the cold data. So this is what I'm saying, and giving an example only for 1 year. What happens if you have data more than 10 years? You still need to carry that every time you take a backup. How big it is going to be? Imagine for 1 year you're having 1 terabytes of database. For 10 years you might be having 10 terabytes. You take full backups every day. What happens? Right? So I'm only giving a simple scenario, but when it comes to a real picture, people are having plenty of like very big databases. Even one table would have 1 terabyte. So there are plenty of very large tables and plenty of issues that we are facing. Challenges what we're facing today is like, and forever, growing databases. We have millions and billions of terabytes of databases, and even trillions it's going on to. So the database keep growing in one day. Available to access. It is not available to access on day-to-day basis. The reason is because you keep archiving, or you keep deleting, or you keep moving, you take backups and plenty of things. That's the problem what we are facing. Then we also have SLA problems. So you need to back up, and if you have any problem within a certain time, you have to restore. So are you keeping up with your SLAs? No. Maintenance is another problem where you need to keep indexing, you have to manage your file groups, you have to manage your files separately, and loads of things. Caution, out of storage, bang. This is the next stage where you will be when you're facing these sort of problems. And how do we really do this in terms of moving this data? So move data to another location. So this is another option where you would see like you would move data from one location to another location, or you will have to buy and add new storage, which is going to cost you more. And you also have to delete and archive data. And what about your SLAs? End of the day, by doing all of these things, you're not really into following your SLA. So that's another problem what we are facing. This is applicable for stretch DB, not just for regular DBAs and backing up these sort of sites, admin sites. So it is totally offsite and geo-redundant. When I say the data is not stored locally, it is stored somewhere else. So it is totally geo-redundant and it's totally offsite. In your regular traditional method, what you would do, you would have to do a tape backup, put it to your offsite. You don't have to do any more provisioning from admin side. And no device and hardware management. That's definitely not going to happen. And no media safety. You don't have to worry about all the media drives and everything what you have. You don't have to worry about it. Remote accessibility. You can access it anywhere, wherever you are, anytime, wherever you want to. And you also can have encrypted backups before taking backups or after taking backups. So it's totally flexible what we have now. And we have some statements from business users and DBAs every time. Business users always keep saying that I want to access all my data no matter whenever it started historically. And guess what? I want to access that in the same application. So many number of demands coming from the business users itself. And also the SAN consumption charges and plenty of things, it's all in the another end. Whereas the DBA side, he keeps saying like uncontrollable growth in size and sprawl and operational windows and SLAs that he has to follow, indexing and maintenance, so much of time taken, and so many other things. And users can't say what data to be deleted. So loads of problems and loads of comments, loads of statements from various business users and groups. I'm only giving a sample here. Now talking about the stretch database itself, what are the benefits that we have? So as of now, we see there are no updates required. What is the meaning of no updates required? So we have an application A, and you have a database B. Now you're moving your database to cloud C, which means you have to make up changes to your application to point to data C when you're seeing your old data. Okay, so this is the change what we have to do, but that's the application what I'm talking about. In this case, there is no change required. You move the data from your database to cloud. The application is still pointing to your local database. Database has got pointers to read from cloud. The end users, they do not know where the data is coming from. Okay, so that's a very good option what we have. And it saves money on storage. You don't have to spend so much money in buying more additional storages, drives, SANs and other things. And also you can improve your performance, and you can back up and restore and no more hassles. Imagine you have 10 terabytes of database and you only have data is just 2 or 3 terabytes. You are backing up and restoring every day, for example. What happens is like the 7 terabytes database, whatever you have in cloud, it stays there. The backups what you're taking is only taking your backups for your local systems, what you have. Your restore time, you compare it, your SLA must be much quicker, which means you have to restore it within a short period of time. Imagine you restore 3 terabytes or 10 terabytes, which is going to be much quicker, right? So you see the difference in that way. And database and table level flyout what we have, and you can pause and disable at table level and monitor functionality. So you can stretch your database and you can monitor it. You don't want to stretch right now, you need to pause it, you can pause it. You can disable it if you want to. So everything is configurable and easy. And you can ability to stretch to a new or already existing server. When we had initial versions of CTP versions with SQL 2016s, we only had an option of always adding a new server. We did not have option of existing server. So everything has been changed with all the release candidates and the other CTPs, and now we have a better product right now. And it supports always encrypted and row level security. Before we start doing stretch database, this is the hierarchy that you need to really see about. SQL Server 2016 Upgrade Advisor is a preview program what we have. So with this application, you can do 4 things. You can migrate to Azure SQL Database, in-memory OLTP Advisor, Stretch Database Advisor, and analyze and migrate to SQL Server. You have 4 options. Of these, we are going to choose Stretch Database Advisor. With that, you have 2 options. When you select a database, it will give you answer to see whether your database tables can be selected or not selected. If it is not selected, it will give you the reason why it is not stretch enabled. Then you can go and fix it if you want to. All right. When it is selected, it would say what are the tables and what are the columns that, or that, like not the columns, the table itself. It will say it is selected or not. But when it is selected, it does not say whether that is local or eligible or remote data. But to us, what we see when it is selected, that is eligible data from all the available local data. Okay. When you have once moved the eligible data to the cloud, then that becomes a remote data. This is only for your concept. This is not part of this hierarchy. We are going to deal with 3 types of data. All data that you have on premises is local. After the stretch advisor says these are selectable and stretchable, then that becomes eligible data. Then when the data goes to remote, then that becomes a remote data. And this stretch database is available in all of these locations. You can use these regions to enable the stretch database. If you don't do it, so for example, I chose a region called, they've introduced a new region in UK, UK North, something like that. And I got all of these problems saying like it is not applicable in this particular region. And how do we enable this stretch database? It is very easy. And you can simply use sp configure remote data archive to 1 and reconfigure it. Bang, then you have it. Or via your SSMS, SQL Server Management Studio, you can right click on your database and choose tasks and stretch and enable. Then you can select what tables need to be stretched. And if you have option, like you need option to choose not just to stretch the whole table, but only certain records in a table. So that was not possible in early versions, but now with 2016s, that is 100% possible. And these are the commands that you would do for pause, resume, and disable. And also you can drop the stretch database, what you have stretched, but it does not drop the database in the Azure cloud. But recently, the change how it has happened is when you disable it, you have an option to bring all the data back to on-premises or leave the data always in the Azure. So you have those options where you can distinguish easily. Let's jump on to demo. Okay. I think I already had the database. Yes, I do have. I'm going to drop the database because I already had once. So what I'm doing here is I'm going to create a brand new database called dagejob_stretch2. Here I'm saying if it exists, drop. And I'm creating this database here with stretch data to data and log, they both being in my local system. And that's the command what I'm using. Once I have done with stretch enabled, you need to pass the master key encryption. So you need to set an encryption key. If you don't do it now, it will ask you with your stretch database advisor wizard. So I'm creating a master key. Then I'm just verifying if the master key exists there or not. So I can see the key returns. Now, we are going to pretend that we have data hot and cold. We are only going to deal with hot and cold data as of now. So for that, what I'm going to do is I'm going to use AdventureWorks 2008 R2 database, and I'm going to run this command to show you what we have here. So we have product key, order key. So it's a fact reseller sales table. It's a fact table where you have all the figures and everything. I have taken only data specifically for two dates, 2005 September and 2005 October. And we have about 1092 records. That's clear, right? So what I'm doing here is I am creating a brand new table called fact reseller sales underscore hot to ensure there is a hot data. So execute. So I have 1092 records coming through. But hang on a minute. I just took 2005 and 2005 September and October data. That is not hot. So for our demo purpose, I'm modifying that data to say anything that is 2005 September to change it to 2016 of May. Okay. Then I'm doing the same thing for 2005 October data to change it to 2016 April. Once I've done, what I'm going to do is I'm going to enable the statistics at the execution plan, what we have here. Not the estimated one, actual. So execute. So you can see you have a table scan operator being, it's been chosen for this particular plan. And you can see the data that's coming through over 1092 records. You see the order data key is showing all for 2016 data. Now, we are going to create a table for cold. So cold data, again, what I spoke is about very, very old data. Here, what I'm doing is I'm only selecting data from 2005 November, but only 5 records. I'm going to add more later, but as of now, I'm creating a table cold, but I'm not changing any dates here, because what we have is, what we need is actually cold data, which means like pretty old data. And a simple select statement that shows you that you only have 5 records on it. Now what I'm doing here is I'm joining the hot data and cold data together and running this to see how the execution plan would come out. So here I see a table scan operator and another table scan operator from cold and hot. Okay, they both are there. So I hope you all know, like, the arrow marks what you see is more thick is based on the number of records that are rendered. Here we only had 5, so it's the arrow mark is very thin. You see that, right? Okay, next we are going to enable the stretch database. So what we do for that, let me refresh. So we now have DBA stretch 2. I'm going to tables. So I now have cold table and the hot table what we built now. On the cold table, I'm going to simply right click and I'm going to say stretch and then say enable. See, this is a stretch option what we have in 2016. So with that you have enable, disable, pause and resume. So this is the only option we have, as we haven't not enabled it. So when I enable that, I get this wizard, but there is a problem on it. It does not show. Okay, that's perfect. And I click on next. It is saying that it is eligible, but before this I have to show you the tool for the upgrade advisor. The reason why we chose exactly that particular table from AdventureWorks, this example will show you. I'm choosing the server and then say connect. I have a little problem here. The window size what I chose was, I couldn't minimize these or maximize it. I mean, like, that's the minimum that I can do it. What it happens is, like, usually let's to move. Okay, that's not happening. So basically you see that I'm going to select the database there, and then to the left I'm going to click on run. When I do that, it's going to select the tables underneath that, then it will say whether the table is eligible or not. If it is not eligible, it will say why it is not eligible. Because of the screen size, I couldn't do that one. And these are the other options that I was saying you in the upgrade advisor. Like you can migrate to Azure SQL database, so you will have options to see. This is an advisor which will help you to upgrade, and also to enable the in-memory OLTP and column store in the advisor. Then the stretch database is what we are talking about, and we also have analyze and migrate to SQL Server. So this is a preview tool. Now coming back to this, here this migrate table is an entire table here. Instead of this, you have option to choose the rows only what you need to do. But we are going to come to that again when we do a T-SQL script on it. But as of now, let's choose the entire table. Then next, I have to sign into my Azure Cloud. How many of you have Azure Cloud account and then you play with it? Good, all of you. Okay, I'm signing into my account. Now it is going to detect how many subscriptions I have, and then it will enable me to choose the subscriptions what I want. Here I have 2. I'm going to choose my partner network, and then here are the regions that are available. So this is what I said earlier. If I choose the UK North and then I go for everything, so for example I'll show you, I don't have any other servers to choose what I have, so I will have to create a brand new one. So the server name is generated automatically based on what I have chose. So I have to give now I'm setting up the access for the credentials. I think the password didn't match. Oh, did? No. Okay. And this is the master key what we gave earlier. If we did not give there, you will have 2 text boxes here to say confirm for the master key. So I'm going to give the same master key what I had on my database. If you don't have this master key, you can't stretch the database. Here, we had new option here, like use source SQL Server public IP. So with the CTPs and release candidates versions, what I did was I have to go to my browser, and then I have to check what is my IP address.com, and then I have to say 81.134.128. Then I have to manually feed in here 81.134.128.130. So instead of 130, what I do is like from 1 then to 255. So I'm just trying to make sure that if the number changes again, then we would match. Instead of that, what I'm going to do is I'm simply going to use source SQL Server public IP. So it's going to detect the local IP what I have connected here, and it's going to give the access accordingly. So I've chosen this, and it gives me an approximate pricing. So it says like $61 per terabyte of data per month, or $912 per month. So it gives us an estimated option pricing, and it says what are the tables to be stretched. This is the place where it's going to throw an error for us. So what it is trying to do is like it's trying to provision the Azure SQL Server stretch database. It's not just that, it is trying to do this provision in the cloud for the region what we chose. The region what we chose was UK North, right? So that region is not eligible for stretch. You need to see the error what is throwing up. But then what happens is like you won't have options to go back and say like I don't want to choose that region, I want to choose some other region. But unfortunately you have to close it. You have to come back again to do the same steps what we have done earlier. See, the first step as said, it has failed, and the message says like operation to create resource group UK North is totally failed. So I have to close it. Let me minimize that. I'll do this very quick so you don't have to follow on that. Next. I've already signed in, so it's taking the credentials from that. So I'm selecting a region called West Europe. I'm searching if I have an existing server. No, I don't have, so I'm going to create a new server. Next. And that's the password that I've given for my master key. Next. Source IP. Next. That's it. Finish. So with this now, it should create the connection between your local database instance to the cloud, where you're going to put all the data from your local system to the cloud. I've chosen to put all the data. So I have one more example to show you how you can write a simple function where you don't need to monitor. You can set a strategy to say, like, from this year, it's 2016 minus 5 years, anything before Christmas of 2011, I want to move that, I want to consider that as cold data. So this changes for now moving monthly by like year by year basis. What happens is, then when a data grows more and more, when your criteria changes as well, it will affect the table, and the table automatically will send to cloud. You don't have to manage it. That's so cool. And as you can see, now the provision has been done. It has created the firewall rules, and in the firewall rules we can go and change if you want to in the portal. I'll show you how it's going to look like in the portal. So let me log in into the portal while that's running. Okay, so that's my portal. Configuring taking a bit. It's again based on your network connection as well. And so where do I see it? Here it is. So the server has been created, but the configuring is still in progress. So let us not disturb for that one. So this is in West Europe, and this is based on my one of the subscriptions what I have. How many of you are planning to try this stretch database option? You have any needs to do this so that you can save cost storing all of these in your company, or you can push your company to say that, yes, we need to save some money because we are already doing this. This is a cool feature that you could do it. And when I click on that, what it's going to do is, it's going to, come on, it's going to create a SQL Server for that, and also for a database for it. It's taking more time than regular. Okay, so that's passed, that's done, good. So close that. Now you can see this icon has been totally changed. Do you see it? It's not a regular database icon. It's the stretch, it's saying database and arrow mark to cloud, which means that database is enabled to stretch to the cloud. Now when I open that one, refresh it, open that one, and I don't see any changes on the table level things. But if I go back to the same table, right click and say stretch, now the enable is gone. You have option of disable or pause. Okay, so this is an easy option for you to manage. This is one of the places where you could manage, or you can go to the database level, then go to tasks, and you can see stretch. You can do the same enabling from this place also, and you have an option to monitor. Now let's not do that. What we'll do is have a simple 3 statements here. System stored procedures, system views. What we have here is, it's saying whether the database is enabled, yes, and what are the tables that are there. And let me try this separately to show you what are the data has been migrated. So what I've done is, here this shows the migration status, and I'm ordering it by end time UTC. So which means I have, when I keep retrying, then I can see it slowly moves the records to the cloud. While that is running, I'm going to open the second one to see the usage. So this is my local hot table. It says I have 1092 records, and in cold we have 5 records. That one is still moving. Okay, so now you see 5 records have been moved. It keeps constantly checking the table. If any new data has been added, it sends automatically. Now I can see as a cold table, the space used is 5 records, reserve 216K, data is 16K, index size and unused. When I use these commands, local only and remote only, I can see how many data is residing in my local system and how many data has gone to the cloud. So here I see 0 records in my local and 5 records in my cloud. So that's in the remote only. So I give some at mode command to say how many data I have and what is the data size stored there. So this is a simple command to see the storage where it has been located. Now coming back to this, what I'm doing is I'm going to insert some more data into the cold table. And I'm seeing the migration status. See, it has gone immediately. It is not going to block your existing CPU memory resources. All it's going to do is it will wait for any heavy loads that are happening on the server at the moment. Then it pushes when the server is free. So it is not going to hammer your server actually. Now you have 11 records in total, all residing in the cloud. Okay, so that's a very good feature what we have here. What happens if we move more data? I'm inserting all of the data record from the sales. So we have 60,855 records. Okay. Let's see the status of how the data is being moved. Now you can see it has moved a chunk of 9,999 records in one shot. It cannot produce all 60,000 records in one go. So it breaks into chains, right? And then you can see 9,999 has already gone. Execute. Fourth one. Okay. Now let's go to the stretch database and then see the status of data residing in local and also in remote. In local we still have 861 records, which means like it is not still saying, the data is still moving. Okay, so if I'm going to refresh, the number should change now. So all the records are now gone. So 0 in local and 60,866 in your remote. So you see the difference of how you can easily move the data. Now what's the database size? What you see here. Okay, so that's a very good example for you to see how you can do a stretch database on it. I'm going to do the same stretch but with a condition on it. Go on. It only says the local one. It does not say for the, I mean like you can see the space occupied for the table locally and also remotely. I've already shown you that command. Let me show you again. See, that's a simple command, says I want to see the space used for this same table, local and also remote. Okay, so let me execute that again. You can see the data size, reserved and unused, index size, things changes. It keeps pointer locally, but it does not store the data locally, physically. Okay, which means the data is staying in the remote. Next.
What about the statistics? Do we have still statistics if we have statistics?
Exactly. I'll show you the execution plan and statistics, how it comes out with. You remember the hot and cold data, the union all statement that I ran earlier? So let me run the execution plan. Sorry, I also want to show you the new feature, live query statistics. This is a very good feature for us. So that's live query statistics on it. So execute it. You see the data is getting computed, and that's coming from a remote query. Did you see that number moving arrows, right? So it's reading the data. It chooses the operators from locally, and it chooses the local table scan. It does still do that local table scan, but that table is linked to the remote one. So you get the data from the remote via this local physical table, and then you see the data outcome. Okay, so that's a very good feature where you would see the operator has been changed dramatically. Okay, we also can move a table, I mean like not the move, stretch a table which is encrypted. So in here I'm using the same database. I'm going to create a new table called fact reseller sales AE, which is always encrypted short form, and let me create that, and then I'm getting all of the data from fact reseller sales to this AE all. So we now have two big data, I mean like two big table actually with the same number of records. And for this I am checking the data count what I have. So again for this AE, so we have from 2005 to 2008. Okay, for our example what I'm going to do is I'm going to manipulate the old data where it is 2008 of May, I'm going to say it is 2015 of August, and here if anything after 2008 of 2008 March and before this particular time, then I'm going to say to put into this 2005 July, and the same with 2015 June. So I'm basically what I'm trying to do is, you can see this here. So all 2008 records have now become 2015 records. Now I'm going to set a strategy to say if any data that is prior to 2011 December onwards that needs to be moved to stretch to the cloud automatically. We don't have to manually interfere there. So what I'm doing here is, next I'm going to create an always encryption. Sorry. Tasks and then encrypt columns. Have anyone played with encrypt columns? Yeah. You can see a quick glimpse here. Okay, so this displays all the available table here. In this I'm going to select extended amount and see if that is eligible or not. I'm like, can I encrypt that column or not? It says a tick mark there. So this column will be encrypted. If I choose any other column, for example career tracking number, and I choose a deterministic type, it says an error. So the collation will be changed from that particular to this particular because that collation did not accept it. So let's go with easy one, extended amount, deterministic, and that, and say next. It is going to auto generate column master key, and it's going to store in the Windows certification store itself. Otherwise you have option to store it in a Azure key vault. And it is giving some caution to say the total size of encryption data is about 11 MB and other encryption decryption is in progress, that sort of thing. And it says the final summary to say what is your new master key, what is encryption key type, and what is extended amount encryption is going to be. So this is going to be much more quicker. We have about 60,000 records, so it's going to encrypt for every single data. So before we had some, let me show you what it looked like earlier. So that's the extended amount. We see some values on it. Okay, and now this encryption is in progress. So what we can do is, I got this query to show you how the encryption looks like. Okay, oh, this one. I'll try run both parallelly. Okay, so that is done. Close. I'm going to execute that. You see the difference? So that's the extended amount before encryption, and this is after encryption. Now I'm going to create a basic function, but before that I'm going to verify if my encryption has taken place or not. So what I'm doing here is I'm trying to select data from all the available columns by joining with column encryption keys on this particular for this particular table, and I see the extended amount has been encrypted. So these are all the columns available on this particular table. Okay, so of which only one has been encrypted with the CEK auto 1. And here I'm trying to create a function. So this function, what it's going to do is, it's going to create a condition on the stretch, and I'm declaring a variable there, date column. It's going to return a table to say 1 as eligible, where date column is less than 2011, 12, 25, which is anything before Christmas 2011. Let me create that function. And once that is done, I'm going to check the whole data. Still it is 60,855 records, and I'm going to verify of these what are the data that will be stretched. So how many data we had? 60,855. So let me execute and see. Now it has come out with 47,572 records. Is that clear? Can you see it? So it's going to stretch 47,000 records. How it's going to do? With this simple select statement on the altering the table. So alter table, this table name, I'm going to set remote data archive with the filter predicate of the function what I've created, and I'm passing the order date key coming from the table itself. And migration state, I'm saying it as outbound. Here if you say post, which means it's going to pause it, and here it is outbound. Let us execute that. And we have not done anything to do with stretch database, which means like we have not done the wizard, we are not done like, okay, stretch this particular database. All we have done is created a function and enabled the stretch with the tcycle statement, not with the wizard. And now what we're going to do is to try and execute this statement to see how many data that is residing in both the sites. So as of now, in local we have 60,855 records. In remote we still have 0 records, which means it hasn't moved yet. So let me go to this window and try and see what is the data movement looks like. This still hasn't moved yet. So you see like it has moved to certain time, and then based on other timestamp it keeps searching for any data that is being changed or not. But before that, whatever changes we have done hasn't taken place. This is the best place for you to look to see what are the tables that have been stretched. Earlier it was showing only one record, and now we have second record, which is fact reseller sales AE_all. So let's go back and search for the status. Execute. Now you see some of the data has been moved recently. Now let us try and execute this. You see the results. Earlier it was 60,000, and now it is going to be 13283. So which is what I have written down here, 13283 and 47572. So we have 47,000 records sitting in the cloud, which has been stretched. You have not done anything. If I'm going to query, or if your end users are going to query this particular table, no matter whether the data is in last 5 years or before 5 years, they're still going to get the data results. Clear? Now if you check the data by order date,
Even though the space used there is very high, it won't actually take that space, or will it?
which space actually?
When you were looking at the space used there on local, it
Mhm.
had no rows, but it had a large amount of data that it reserved.
And that's something like we need to work on. So when it initially created, the numbers keep changing and jumbling around here and there. And even when I tried to do the calculation of what is the actual size on the database, whereas these particular things were showing different numbers. When it is moving here and there, the numbers don't match. It matches probably after some time.
Right. Okay. Like if you delete a massive amount of data, it takes.
Yeah, it's still moving out. So I'm now checking the data by order date. So I still see that these are the records that are actually in local. Now I'm not changing anything to my local system, but in 2011, sorry, we also have data from 2015-0801. So I'm taking this latest data, which means it is getting more matured. Moving forward, if we predate this date to a date here to 2011 November 30, which is before the target date what we set. Execute that. So it says 5,800 records have been affected with that, with the changes. Execute. So we have now 13283 according to that, and if you go to these and check the status, no migration as of now, but when you keep looking at it, it does not do immediately. So it does when the systems are like not really too much CPU pressures or something like that. So now we have 5800 records being moved. So that's the records. Now if you go back to here and then search for it, you can see that 7400 staying locally, 53,000 staying in remote. Okay, so that's a stretched database where you can clearly see how a stretched database would work for a normal users. You can easily stretch it to the cloud. When you have your cloud account, set master keys and everything in hand, you can save loads of money and you can get promotions quickly as well.
What's the object in Azure? Just a VM?
Sorry?
Is it a SQL VM in Azure?
Yes, yeah, of course, yeah. We got to 2016 VM. SQL 2016 VM for you to demo.
No, I mean, what it's stretched to into Azure? Is that just a SQL VM that's sat there? Can you log into it and look at it?
No, it's not a VM, but it is stored separately as a stretched database. You have Azure SQL database, right? Similarly, you'll have this database separately. I have this, my portal here. If I go to my SQL database, I can see here the new stretched database. Oh, sorry. So in my SQL database, I already had a database that, and this is the newly created database. So you can access it as a normal Azure SQL database. It does not create any virtual machines for that. Okay, SQL Server deployments, like to answer your questions, like as of now we have plenty of options. In terms of on-premises, you have traditional physical server and a virtualized physical server where you have your private cloud, your own one. And in cloud, you have Azure SQL database is what we saw, and we also have SQL servers on your Azure virtual machines. If you go now to the cloud, and then you can spindle up your own thing to see SQL Server 2016 and any other things based on Windows servers. This is SQL Server deployments which are available and very, very effective for us now. Let's go on to backups. I'm going to talk a little bit on these backups before we go, because we definitely need to do something here. This is the one is anytime expected disk crash. Earlier this morning, like another presenter, Gianluca, like he had a big one delivery and his hard disk crashed and he couldn't do the demo, so he had some problems running into it. So it can happen anytime, and you always do this. You always make sure your data is not lost. So you keep taking backups, backups, backups. By the way, did you take your backups before coming here? If not, did you had any backup for you to take your backup? This is just a reminder. I'm taking this opportunity to remind you that if in case you have done or left something in the halfway. Okay, on-premise to backups to offsite. Why do we do this? So for redundancy, we have DR plan and we have cost. You can't keep storing all your historical databases locally every time. So you're going to occupy space, cost, storage, everything. And how do we do it today? We tape backup and we store it. Either we store it in a locally systems or we transfer it to some other offsite place. And again, if anything happens here, we still have access to the database. So for that reason, you can restore it at any point of time. When you store it in a different place, this is how in one of the environment where you have your tape backups. So you have a computer system, you say like for this company, for this one, exactly. The machine identifies it and goes and picks it up and comes out. So you don't have to go and manually search for these things. So there are huge things that are available with this particular searching on the tapes. And again, once you have done your tape backups, did you check any tape backups that you have sent to offsite is recoverable? Can you restore it? Did you have that opportunity for in your location? So if not, you have to try it, or you have to speak to your DBAs and admin guys to say like, hey, you're sending backups to some other place, and have any day, do you have any SLE or something like that to try whether it is restorable or not? You can raise these questions. So that's again another good tick mark for your promotions. Backups are required, definitely. So to protect against hardware or media failures. But this we do for an on-premises thing. But as of now, we have backup options where Azure VM takes care of your hardware and media failures. You don't have to worry about anything. Okay. Then DB backups are still required to protect against user errors, archival purposes, regulatory and admin purposes. Then you have to worry about these backups. No more fuss with backups, tapes, and shipping, because all of these processes are totally eliminated now when you're trying to take your backups to cloud. What are the options we have as of now with the backup features? Like you have backup to your URL, which is like Azure blobs. You also have SQL Server managed backups, and you have file snapshot backup. So with backup to URL, you, instead of giving a backup database command to a certain drive, you would simply give a URL command. URL points to your database. Have anyone tried the backing to URL? Backing a database? No? Not yet. We'll see that in the demo. And we also have SQL Server managed backups. In this one, what you're going to do is, all you have to do is set a retention period and give a storage location. It will take the backups on its own. It manages it. We don't manage it. We don't have to worry about it at all. It stores everything. You have to say retention period. Let's say 30 days is a number. Anything before 30 days, it deletes automatically. Okay, you manage it. Like you do it and the SQL Server manages it. Then you have file snapshot backup. This is fastening speed. I'll have a demo for this on that as well. This snapshot backups is like, it takes a snapshot of your existing MDB, MDF and LDF files, and then it takes a backup of that snapshot. You can think taking a backup of MDF and LDF itself, it's time consuming. But taking a backup of these snapshots, it's a two-way process. How come that to be faster? I'll explain that quickly. Then moving on, with the storage account, you need to have a storage account, and then the whole storage account is your Azure cloud where you have it, and you need to create a container. That container will hold all your blobs. As of now, we have two types of blobs. One is page blobs, the other one is block blobs. So anything that you place in a container, if you're trying to give access to one of the blobs to a person, you're only giving access to the particular container, not to the whole storage account. So you're accessing, or you're giving access to anyone only for a certain area. You're not giving the whole lot there. And as of now, as you can see, you can store 12 terabytes of backups online with blocks. With the page blobs, you can store up to 1 terabyte. But with this one, 12 terabytes, but not just 12 TB just like that. By default, if you take a simple backup to cloud, to URL, you can only take maximum of 200 GB. That 200 GB, you may have more than 200 GB of backup. In that case, what happens is, you can take stripes. So you can split them across. So if you have 1 terabytes of database that you need to take, you can see 5 stripes. It is much more fast. It's going to take the same time, which means it will have 5 different files, 200 GB of each, and makes it 5. Like that, you can do up to 64 times, which is about 12.5 terabytes, something like that. And this particular Azure backup to URL was introduced in 2014, and then they went back to SQL Server 2012, Service Pack 1 Cumulative Update 2, and that also applicable there. And now we can easily migrate all these backups from 2014 to 16, and you can schedule based on workload, which means you can schedule and run these backups if the workload is less, and the system will decide on its own. You don't have to worry about, I have a huge applications running and I have business users running and I don't want to take my backups now. We do quiet periods like evenings and weekends, something like that. But as of this, it learns the workload and you can do it that way. And you can access only the container like I said earlier, and you don't have to back up the whole databases. You can back up only certain files and certain file groups, which makes our life much more easier too. And restoring process is also much more easier. With this process, no more tape backups, no more sending to offsite, no more recovery process for them to come back again. So there is a very big process. You totally ignore those ones. So this is an example for you to say the MDF, NDF, and LDF store in on-premises. With the new option, you can create a database totally on the cloud with all MDF, NDF, LDF stored on the cloud. Okay. Now, we also have combination of hybrid things where cloud and on-premises together, where you can store your MDF locally and NDF and LDF and backup files in the cloud. So everything is possible. You don't have to worry about, you don't have a storage here. So those days when I used to do a demo of how I have files and file groups in the database, what I do is I have a drive system where it can accept more than one USB drive. So I place one of the NDFs and LDFs in each drive, and then what happens if one crashes? So I take the USB drive out and then I try to run the query to see if that would work or not. But now we don't have to worry about, everything has been changed to cloud. So one NDF can store into a different place. Do you understand the concept what I'm talking about, right? Good. With SQL Server Managed Backup, again, this one enhanced more now with, you can use full bulk log and also simple. All the recovery process is available. You can also configure system DBs. This again does the same Stripe backup, which is the block blobs with up to 12 terabytes. You can schedule based on workload. This managed backups also maintains it. And you can migrate from already existing SSMB to 2016. And again, you can do with the files and file groups. I want to show you a snapshot. This is also a different angle and view and perspective of what we actually understand as of now. The snapshots, what I'm saying is like the database state 2 years ago, how it was and how it is now. If you want to recover something 2 years back, all you have to do is you have to ask a person to come and recover it, transport the tapes, and then you have to copy it, restore it, you have to make it active. So it's going to take so much of time. So with the file snapshot option, this is the lightning speed things. But here I'm going to give you a basic picture of understanding how it could be with my real type example. So this is a picture of me, and I weigh 110 kilos at the time. Okay, this was in 2009. The reason why I'm showing here is this I transformed into this in 2010. Within less than a half a year, I became like this. I worked hard, very hard. And this is how I looked when one of my presentations in Malaysia, this is in 2013. And trust me, for this session, particularly for the Inside SQL, I have a different look to show how I look now. I don't want to put a picture. So I'm trying to dedicate on one side to show how a picture looked like. Just for this 5 to 10 seconds of speech, why should I have this look? But that makes more sense to understand how it is. All I can do is, if I have any problem that I had 2009, I have to recover that, restore it to the process now. I can't do it, right? But at least I have a memory of how I looked at that time. So I'm just trying to give you a simple picture of how things would move. The examples what I'm going to show will give you more ideal things as well. Disasters do happen. So we also had problems with this tsunami in 2004. We had this 9/11, and also we had these hurricanes, Katrina, and also we had this earthquake in Japan, earthquake and tsunami together at the time. So it was totally disaster. During this time, what do we do for our backups and everything? So backups is a very important thing in our life, and how do we restore it? In this file snapshot, this is a very good example for us to understand. So usually we had a picture in the Stretch database always to say like there is a line where you have your local on-premises and where you have your Azure databases. With this example, everything is in Azure. You don't have to worry about anything. So this is your SQL Server instance. Let's say it's a virtual machine, or you have a SQL Server instance there. Then here you have the Azure blob storage, and you also have one more Azure blob storage here. This particular SQL Server has got its MDF, NDF, and LDF files in the blob storage. Okay. Now, when you're trying to take a file snapshot backup, what it does is it immediately creates a snapshot of your MDF. Again, snapshot of NDF and snapshot of LDF. In this blob, what it does is it creates a pointer for the database to say which snapshot and which MDF is connected to each other. With this, what do we understand is we take backup of not the original MDF, NDF, and LDF, but we take backups of these snapshots only. If you have to restore to a certain point in time, this is a point in time restore. You can go back to that particular day, you can restore to what data it was at that time, and that is much more faster. And also one more concept with this file snapshot is you take regular backups in your traditional method of full backup, then you take transactional backup, also you take differential backup. How many of you have done backup process? Yeah. So you understand the process. Let's say you have one full backup, you take once in a week, then you have 10 differential backups, then you have 20 to 40 transaction log backups. This is due to some sort of requirement what you have in your company. If you have to restore to a certain time, all you have to do is first you have to get the full backup restored, then you will get your latest differential backup, then all the log backups taken after your latest differential backup. This is the way it could be, and see the time taken to restore that. With this concept, you would still take full backup, no differential backup, all transaction log backups. If you have to restore after 15 attempts, like if you have 15 transaction logs been taken, if you need to restore, you're going to restore only the log backup which you have taken, which you need to restore before and after. Only 2 restores, it will restore the whole database for you, and the time taken is much more quicker. I have tested this in a real world example. One of the databases, when I tried to restore, it took about 30 minutes and 50 seconds, something like that, and with this file snapshot restore, it took less than a minute, not even a minute, actually half a minute, something like that. So that one was that faster. Let's jump on to demo. How many of you played with Azure storage, blob containers and blobs, creating those ones? Okay, here you will learn very good things here then. Use master. I'm using this master database to create a credential. So basically, I have an application called Azure Storage Explorer. Not here. Maximize. Okay, that's good. I have an account in cloud, and that is called DBA. Here I have 3 different containers: backup container 2, container DBA 1, container DBA 2. So you can see nothing is there at the moment. I'm going to create a credential for container DBA 02. Okay, this is available here. If I don't have, I can create a new blob container. As I already have one, so container, let me delete and open one for you. Blob container, new. I'm saying CT or DBA 02. That is a container. I'm making it as public container and say create. Go refresh. Okay, it didn't like that name. Okay, so it had kept the reference earlier, so it didn't allow me to create with the same name. So I've created with CTR DBA 04 as a container, and I can see that there. Now with this example, I have CTR DBA 02, so I have to change them all to that. So what I'm going to do is, I'm going to replace anything with that to 04. To create the credential, this is the full link. So DBA is my blob account. When you create a blob, the blob gives you this link, blob.core.windows.net. With this credential, I have to create a shared access signature to a particular container only. Where do I get the secret key? Again, if I go to this CTR DBA 04 there, I click on it and I have a security option. And I go to shared access signature. I'm going to say I need access to read as well as write. And I'm going to give this access to be permitted from 14th of June from that day to 21st of June. I then click on generate signature. So this generates a signature with the whole of my container details as well as the secret key. So all I need in here is only the last 2 part. So I copy that. I paste it. I've created the master key now. I'm sorry, shared access signature credentials. To see the credential executes, I already have plenty of credentials here. One among them is what I created now, which is the last one, DBA 04. And this is the database create database script where it says where the file name is database in Azure to that, and file name is going to be that. So db in Azure 2.mdf. Earlier I showed you an example of how you would keep your MDF and LDF files in your cloud. So this is an option for us to see how you would create a database in the cloud. So I execute that. While this is executing, I can go here and then go back there to see the two MDF and LDF files are based in here. So that one executed in 7 seconds, which is good. And here I'm going to drop the database and create a database for what? Okay, so sorry, this is an example for you to show to create a database having the MDF and LDF in the cloud. Okay, that's an example of what I've shown you there. And for our for our database backup and other things, this is the example what I'm going to show you. So I'm going to create one more database called DBA to Azure, and also I'm creating a table with ID number on it. I'm setting the database recovery status to full. Then I'm taking the backup database to this URL, which is again container dgf04, and saying dgf Azure BAK file. So I execute that. Oops. While that's running, let's go and refresh it here to see the new backup file what we created here. So this is where you see two different options, page and block. I told you earlier, like we have two types of blobs, page blocks and block blobs. Page blobs are the MDF and LDF files, and block blobs are the BAK files what you have there. You can't control it, it's controlled automatically by the system, and block blobs are 2 times cheaper than page blobs. So here you can see this backup has been created. So now we built a database purely on the cloud. We built the database locally. Is it local database what you built? Yes. And it is being backed up to the cloud. Next, we are trying to restore the backup file from DBA Azure 2 to Azure itself. So you understand the concept. We create a local database backed up to the cloud. Again, from the backup from the cloud, we are trying to restore back to the cloud as MDF and LDF files. It's all going back to the same container now. So as you can see now, DBA to Azure MDF is there, and log file is also there. Okay, so that succeeded. And this is an example of striped backups. So in a regular backup, what you said was backup database to URL, just only one. Whereas for a striped database backup, you would say backup to database with URL of how many you want. In this example, it only allows 200 GB of one backup. Now if you have 1 terabytes of database to be backed up, here you would say 5 different stripes. So it breaks up automatically. So let's try building a backup as striped one. I don't know how that changed. This is not the time to do it. Yes, I know that. I replaced everything. I think yeah, I did that right. Okay. Okay, that worked now. So stripe backups, I'm refreshing that again. Let me expand this. You can see all 5 backup files are going to the cloud, and you can see the length, the size of the backup files. So it has created a backup. Now if you want to restore all the striped backups to a local system, then you would do here. So you're going to restore the database DBA to Azure 2. So what I'm going to do is, we already have a local database, so I'm going to say this as 3. I think again this is not going to work. restore, exit, execute. These all copy replace problems. Sorry? Did I say that to? Thanks for that. It says cannot be overwritten. Yeah, I got replace on it. Okay. I changed the database name because I want to show you an example of how we backed up from Azure 2 and then we restored it as Azure 3. Okay, so that succeeded. And we have seen an example of how you would backup and restore from a database locally to cloud, again cloud to cloud, and with Stripe backups as well. So that's a good example for us. Next, let us dive into SQL managed backups. This is a bit tricky here because when I tried these queries earlier, it did not work, so I have to run some PowerShell commands. So what I'm going to do is I'm going to use the PowerShell to generate the scripts. So here I have DGO with backup container 3. So I don't have this container as of now. So I got to change the container. I'm going to say new. Let me say 6, create. That's there. Your container 6. And I'm going to get the secret key for this. Read, write, and also we're going to do deletion as well because it's going to have managed backups, right? So the retention option, it should delete. So we need to give option to delete as well. So that's a command for that. Before doing these managed backups, I'd like to show you the file snapshot backup, and then I'll jump to the managed backups. With the file snapshot backup, we are again using the new container here, which is backup container 3. So let me create the backup container. I'm saying new. I'm sure you should be getting used to creating the containers and then using the other ones, right? So I'm going to use backup container 5. And then I'm going to replace here all from backup container 3 to 5, replace all, and I have to give the secret key for the backup container 5 shared. I'm going to read, write, and delete, generate. I'm going to copy the last 2 lines and then that. I'm going to create a credential and succeeded with that. And now I have this file snapshot is only permitted on the files that store in an Azure storage account. If you have your database stored locally, this will not work. So you have to have, unfortunately, the account backups to be available in the cloud. So I'm going to create a database with the same backup container. Execute. Close that. Let's go to the backup container and refresh it. Okay, so we now have MDF and LDF, and we are going to populate some data. And before that, let me create a table, and I'm populating some data. Execute. We are running out of time, so this is more interesting than the managed backups, where you can clearly see the time taken to restore a backup is much more faster and quicker compared to the other one. So this is basically now generating the data. So if you see the size, it's 8 MB, and now when I refresh it, you can see the size is going up. So that's executing on one side. And here I have option to back up the database. This is the full backup what I'm taking, first one. So with the file snapshot backup, you have to trigger the log transaction backup only based on your full backup. So this one has taken about 34 seconds. I now have some data on it. I'm taking a full backup in the backup container of Hive. So I can see now dayjob04 back, and that is taking as a blob. And once that is completed, yeah, that's done, then I'm going to take a log backup, and it says backlog successfully processed with 0.56 seconds. This is the traditional backups that you would do. Okay, I have file snapshot backups that I want to show you also. I'm going to generate some more data here, and I'm taking backup 3, 4 again, and I'm populating some more data. I'm only taking 5. I'm not going till 15. So this is the last log backup. Execute. So going back to Azure Storage Explorer, I'm refreshing. I can see all my backups and transaction log backups are all staying here. Clear? Now we have to try and restore it and see how long it takes. That's a traditional way.
What's the underlying technology being used for the file snapshot?
For the file snapshots.
Yeah.
Like I said earlier, the file snapshot before taking the backup, it does not take the actual backup of the MDF and NDF files.
Right.
It takes a snapshot of that MDF and LDF into a snapshot file. Yeah. It takes a backup of that snapshot file, which means it's a... Sorry? Have you done the snapshots, database snapshots in the earlier days?
So it's like a change file?
Yeah, like a change file thing. So,
You can't delete the original data.
but you can go, no, you can delete. Those days you can't, but now you can. I'm sorry. You can't access the backups. I'm sorry, you can't access the file snapshots. You can only access the snapshot backups. It is taking only a pointer. It understands the database. It creates a pointer of what the changes are done at that point of time. It captures them all, keeps it together. The snapshot technology, what they have inputted on this one, is much faster when it is trying to take the backup on that. So it takes only the compressed version of that backup of the snapshot file. So that's why it's called file snapshot backup, and that is much more fast. You will see when I really execute this command. So this traditional method, I'm trying to recover this database. I have to say here something. I have to rename the container to backup container 5. So let me change to that 5. So I got all other names are the same. So what I do here is I have taken one full backup and 5 log backups. I have everything listed here. I hope there are no mistakes on this. Execute it. I'm executing them all together. While that is running, let me open up the file snapshot things. So what I'm trying to do here is I'm going to create, while that's executing, the same database with the same data on it. Here in the backup container, this is 4. We have 5 now, right? With this backup container 5, oh, we already had the credential, so I don't have to create the credential again now. So all I'm going to do is create the database. The early database was 04 only, but now here I have dayjob04 fs, which means file snapshot example I'm trying to give there. So I'm creating the things. I think the backup is completed. It has taken 40 seconds. I'm sorry, restore has completed and has taken 40 seconds. And in here, once that is done, I'm creating the table and I'm populating the data. It was quick on the other session, like it was the same number, 600,000.
Explain the time that the snapshot is taken, a long transaction. We have a long running transaction.
No, no.
No, it's not going to take the.
It'll be much quicker compared to your traditional backups what you're taking actually.
No, but the database will be in a clean state in any case. It's not the file based snapshot.
It's not file based one. No,
File-based.
no, exactly. So this is done. So then I'm taking the full backup here. Then I'm having 10,000 records. I'm just adding some more. That is quick, good. And I'm taking log backup 1. And I'm taking log backup 2. Then I'm adding additional 10 more thousand records compared to the traditional one. Then I'm taking snapshot 3. And here the only keyword what we are using is with file snapshot. That's it. There's no much difference between a traditional backup and a file snapshot backup. And I'm having some more data on it. I have more data, so hopefully this should work to be much more faster than what we are expecting with that one. So this is a quick example to show, what is it? Did that work? Anyway, we didn't refresh this and see. Okay, that worked. So we have this file snapshot, all backups being here.
I don't think you allowed it list status with the security.
I did.
In the security.
To read and write and delete or something like that.
Yeah.
Yeah, I gave all the 3 checkbox.
There's 4 checkboxes.
Yeah, the first one is not required.
That's the list one, isn't it?
Yeah, this is only the file snapshots, what I'm trying to do. Okay, let me show the restore ones quickly. So I have that's backup container 5. So in our example, so we are trying to restore the log backups 4 and 5. You see the command here. I understand why this or that. I'm restoring the database from the transaction log file. So the transaction log file of what we have taken, the 4th one and the 5th one, is what we are trying to restore now. So in here, I'm restoring the, I'm going to do them both together. That one was another blob account, actually, storage account I had. So that's the right one. So let me execute that. Use master, go. Execute. Cannot be overwritten. I already have the data. I had this with replace. Okay. I should have cleaned it first. Okay, what I'm trying to do here is I'm trying to restore that onto the same one where I have this MDF and LDF file residing. So let me choose the DayTube container 6 where I have it. So let me get that right. Now the first one was correct. That's where the backup reside. and the transactions back up. Thank you. I'm just running out of quick times here. Before that, let me verify the backup container timings. Here, I have 5, 9, and 41. Yeah. So that one is in actually BST time, so that's why it's minus 1 hour still. Come on, this must be much more quicker than the other one. All verified scripts, but it fails always at the demo time. Okay, while that's running, let me go back to these slides. So this is the SQL Server Azure tools what we have. We have the SQL Server Management Studio, Azure Storage Explorer, what we saw earlier. We have AZ Copy, PowerShells, Windows and Azure, Azure CLI, demand database migration, Visual Studio, Redgate Cloud Services. So it gives you some description on what exactly it does, and also we have on-prem, cloud, and hybrid, and where can you get it downloaded. So this PDF document will be available, so you can just easily download the documents and tools what you want to use it. The last thing what I want to cover is the high availability and the disaster recovery. This is to do with always on. How many of you tried always on? Yeah, so good. So with this always on, like we now have a very good feature. So we have these on-premises ones, and now infrastructure as a service we have only last 4. With platform as a service now we have all of these things. So you manage it. All the red ones and the green ones are now managed by Azure, which is a very good thing for us. You don't have to really worry about this. So you're taking a photo. Okay. Then high availability and DR from Always On. So Always On was released in SQL Server 2012 as a replacement for data mirroring actually, and it requires WSFC, which is the Windows Service Failover Cluster, where you will have to have SQL Server cluster nodes instances, and this is a replacement for enterprise level replacement for data mirroring. Data mirroring was introduced in 2005 as high availability, but that worked in standard edition, whereas the replacement of these Always On requires only enterprise edition. That is in 2012, and domain independent is available now. The main difference of this always on is those is when you configured always on, you need to have the same domain, whereas now we can build the without domains, with trust or without trust. It is very easy, and it is much more powerful than the earlier one. As we said earlier, it is replaced with 2012. It used to work in database mirroring standard, and now it's totally available in your 2016 in the standard edition. Also important fact is like it does work with tiny restrictions on it. Any questions? Okay, we already answered some questions over there. Thank you so much. I have to show the demo how long it took actually. There you go. So that took 21 seconds. So you find the difference of how long it took from 40 seconds to 20 seconds, 21 seconds. The database is in use. Work, except this one, it's saying like it's not trying to restore that particular one. But what I have watched earlier before the demo was like the first one took 44 seconds and the second one took less than 15 seconds actually. So which means the restore of the file snapshot was much more faster, right? So when you see a huge database, restore is very quick. Yeah. Thank you.